When we look out into the deep cosmos, we see galaxies accelerating away from us. To explain this motion, standard physics relies on a mysterious force known as dark energy. Making the math of an expanding universe work requires a specific placeholder. Physicists call it the cosmological constant, represented by the symbol lambda. Lambda remains a static number with zero physical justification. It functions as a mathematical patch used to fill a gap in our understanding of how space actually operates. This creates a massive coincidence problem. Quantum theory dictates that the background energy of the vacuum should be enormous, yet the physical expansion we observe is exactly 120 orders of magnitude smaller than what the theory predicts. This glaring discrepancy forces an obvious question. If an invisible, universe-spanning energy field is powerful enough to push massive galaxy clusters apart, why does our own solar system remain intact? Cosmology is stuck. Resolving this requires a physical structure that dictates expansion, moving beyond a theoretical patch that merely describes it. In April 2026, a paper titled Nonlinear Coherence Field Cosmology outlined a structural alternative. This framework defines the fabric of reality as a dynamic, variable coherence field, replacing the concept of an invisible, static dark fluid. This field acts as an active structural balancing system. It constantly adjusts the organization of microscopic space in response to thermodynamic stress across the cosmos. Reality functions as a continuous, self-regulating physical system that actively responds to the matter within it, evolving past the traditional idea of an empty stage. To map this macroscopic scale, we look to the 2PS framework, known as Relational Coherence Cosmology. This framework models reality as an energy landscape, a symmetry-breaking topography where a scalar field rolls towards stable potential wells. Navigating this landscape, it constantly shifts energy to maintain structural balance. Late-time cosmic acceleration is the observable symptom of the field settling into these physical valleys. Dark energy represents the physical manifestation of the entire universe seeking relational equilibrium. This macroscopic expansion requires a microscopic engine, found in the rendering lattice of coherence geometrodynamics. This lattice acts as a processing substrate for the vacuum itself. These two scales are bridged by a single bounded equation. The first half establishes a hard limit, a verified self-regulating ceiling preventing the coherence field from expanding out of control. The second half measures thermodynamic load, tracking the tension between entropy generated by localized complexity and the architecture's physical capacity to dissipate that stress. This mechanism explains why the field doesn't disrupt our local environment. The metric stasis root and harmonic decoupling values show how specific frequencies lock the local metric into stability, effectively screening the field's influence in high-density regions. The structural elasticity of space and the thermodynamic overhead of the universe itself explain the observed expansion, entirely replacing the need for exotic dark particles. This framework generates measurements we can test against current astronomical data. These graphs chart the predicted energy deficit of a photon over cosmological time. We should see a systematic deviation in the distance redshift relation for distant standard candles, like type Ia supernovae. Light traveling from these incredibly distant objects should lose energy purely due to the time spent in transit, creating a redshift effect independent of the universe physically expanding. Verifying these values resolves the mystery of the dark sector. The perceived cloud of invisible dark matter holding galaxies together resolves into the physical elasticity of the underlying geometric lattice. The universe functions as a unified, bounded scalar field, dynamically maintaining its own geometric coherence across the infinite expanse of spacetime.